Hello, Miss Georgia. So let's look at lesson 109 first. So here's the first problem. This is a simple interest problem, right? Let me get my pen. Sorry. Simple interest. So that means that we're just going to find the percentage of 7,000, the 9% interest on 7,000, and we're going to add it back to 7,000 twice because it is 2 years. Okay, so we get interest on our money every year at this rate. So we just do it for the time that it tells us to do it. So 9%, when you have 9%, in order to multiply that, we have to turn that into a decimal. Well, that means 9 out of 100. When we divide that, we get 0.09. So that 0.09 is what we're going to multiply by 7,000. So 7,000 times 0.09. And let's see what that equals. Let me pull up my calculator here. 7,000 times 0.09. That's $630. Okay, so that's 630. Now we're going to take that 630 and we are going to multiply it by 2 because it's 2 years. So times 2, that's going to be 1,260. So 1,260 is the amount of interest that she earned in 2 years at 9% on 7,000. So in order to figure out her total, we're going to add the interest back to the 7,000. So let's just add 7,000 to that. So the total amount that she had was $8,260, and that would be the amount that you put in for this problem. Now let's look at the next one. The second problem says, how much would Elvira's 7,000 be worth in 2 years if it had been deposited at 9% interest compounded? So there's a difference. Simple interest means that it is an interest rate on the original amount that you deposit. Compounded interest means that you're going to earn interest on your interest. So we would do the same calculation. 9% would be let me get my pen back. 9% would be 0.09, just like before. So we would say 7,000 times 0.09, and we would still get the same $630, right? That's what we got on the calculator. Yeah, 630. Only this time, when we calculate interest for the second year, because it's compounded, we get to multiply this number too. So we add that back, 7,000 plus the 630, so plus the interest, the principal or the original amount, plus the interest. That's equal to her first year balance. So that would be 7,630. So this is the balance at the end of the first year. So now we're going to take that balance at the end of the first year, and we're going to earn interest on that one for the second year. So we're going to multiply that. So let's pull up the calculator. And now we're going to do 7,630 times 0.09. And we get $686.70. So $686.70. Now we are going to add that back to the 7,630 so that we can get our total. So 7,630 plus 686.70. This is the interest. So this was the first balance at the end of the year, plus the interest is equal to the second year balance. Okay, so then we add that together. So plus 7,630, we get 8,316.70. So 8,316.70. So the point of these two problems is to show you that you want to have an account when you deposit your money, like in a savings account. You want to have an account that compounds interest. You don't want to have a simple interest account. You want a compounded interest account when you're earning money. If you're paying money, you want to pay simple interest because then you're paying less. But if you're earning it, if it's coming in, this gives you more. So you want a compound interest account that gives you interest on top of the interest that you've earned. That's what the difference is. Because her previous amount was like $82.60. So this is more than that, right? So $82.60 was what she had before. So what she earned more, let's subtract $82.60. She earned $56.70 more just because she chose a better account. Same interest rate, but it's compounded annually, and that's the difference. You got $56.70 more for not doing anything except sitting on your money for 2 years. So the type of account you pick matters. And that compounded word, that's what the difference is. All right, this was the simple, and this was the compound. And we earn more with the compound. So let's look at the next. The answer to this problem, by the way, is 8316.70. That's the amount compounded that we earned, okay? This amount right here. Let's look at the next problem. So here's another problem just like the previous one. If Jennifer put $5,000 in the bank at 7% interest compounded annually, how much money would she have at the end of 2 years? Let me get my pen back. So $5,000, 7% compounded 2 years. So 5,000 times, we have to turn this into a decimal, so that would be 7 over 100 would be 0.07. So times 0.07. Let's pull up our calculator. 5,000 times 0.07. That's $350. If we add that back to the original 5,000, that's $5,350. This is the amount that we're going to compound at 7% interest for the second year. So times 0.07. All right, let's add the 5,000 back to that. Times 0.07. $374.50. So now we're going to add the $53.50 back. So $53.50. $5,724.50 would be your total. And you could just do it like this if it's easier to do on your paper to have it all stacked together like this. So this would be your original amount that you added back to the interest. This is the first year interest. This is the original amount. We add those together. Then this would be the second year interest. And this would be your first year balance. And this would be your second year balance. Right? So this would be your first year balance also. All right, so you just bring it down and add it in. If you were to do that another year, you just repeat the process. You would multiply this times 0.07. You would do that again, times 0.07, get your interest, and then add this balance back to it. So that's how you would find your final total. And that's it. All right, let's do another one. All right, this one says Akeem put $15,000 in the bank at 10% simple interest. How much money did he get when he withdrew his money after 3 years? So the original amount, that's $15,000. He has 10%. It's simple interest in 3 years. So all we have to do is say 15,000 times 10%, that'd be 10 over 100, that would be 0.1. So 0.1 would be $1,500 because we're just moving the decimal point back one place. Okay, when you do that on the calculator, you get $1,500. So he's going to earn the same amount for every year that he's got it in the account. That's what simple interest means. So we can take this simple interest for the 3 years and just multiply it by 3, which would give us $4,500. And we add that interest. This is 3 years of interest is what this is. We're going to add that back to the original amount, not subtract or multiply, add that back to the original, which is 15,000, and then that gives us 19,500 is the amount that he has. So that's how that works. Simple interest means you're going to get the same amount every year. So you find the interest and you multiply it times the number of years. Add that back to the original. That's how much your total is. Pretty straightforward. All right, so now it says, how much would Akeem's $15,000 be worth in 3 years if it had been deposited at a 10% interest compounded? So now we're talking about compounding interest. So we start with the $15,000, and we're going to multiply that same interest is still 0.1 times 0.1, which gives us $1,500. So then we're going to add this back to the original amount, okay? So that's going to be 15,000. That's the original amount. This could be 16,500. Now we take this is the second year, this is the first year, this is the second year. So we're going to multiply that times 0.1, and that's going to be 16,50. So we take this amount and we add it back. So 16,500. And this is the third year balance. So we have $18,150 after 3 years. After the first year, oh, I'm sorry, I did that backwards. Not backwards, but just not enough. Let me erase. This is the original amount. This would be at the end of the first year. Sorry, this would be at the end of the second year. So we need to do one more year. So we're going to take this amount, we're going to multiply that times 0.1, which would give us 1815. And then we're going to add that back. And that's going to be 18,150. This is the balance at the end of the third year. I thought, that's really not enough, is it? For 3 years worth of interest at 10%, that's a high interest rate. So this is your final. Sorry. So at the end of the first year, end of the second year, end of the third year. That's how much he would have. And that would be, he would have gained $4,965 would be the amount that he had earned in 10% interest. All right, let's look at another one. What percent of 68 is 170? So whenever you have what percent, this is going to be your unknown value. We don't know what the percent is. That's why we're asking. So this is going to become the variable P. Of means to multiply. 68 is just the number 68. Is your equal sign. And 170 is just another number. This tells us how to solve the problem. So P times 68 is equal to 170. So whatever the percent is, that's what we've got to figure out. Now we do that through division. We're going to undo this multiplication by dividing everything by the number we know, which is 68. So if we divide that, this would cancel, because 68 divided by 68 is 1. So P would be by itself. And now we just have to figure out what 170 divided by 68 is. Let's see if we can do that. 2.5. So that's 2.5, which would be 5 over 2. And if we reduced this, that's what we would get. We would get 5 over 2, which is the same thing as 2.5. So that is, the percent is 5 over 2, which we said was 2.5. So the percent here, we need to multiply this times 100 to find the percent, because P tells us what format it has to be in. So we multiply this by 100, we get 250, and that allows us to put the percent symbol on the end. So the answer is 250%. I could have skipped this step, but I had a brain moment, a senior moment, and was thinking about, oh, we're in fractions, so let's do fractions, but we really need to go ahead and do the decimal. So this step could have been skipped, is all I'm saying. Let's go on to the next one. This says to use the distributive property to multiply. So we're just going to use the rainbow. The distributive property is another word for the rainbow. We're going to distribute this to everything in here. So then this times this is 3cm. This times this, 3cmn. And this times this is 3cn. That's all you can do. That's all you can do. That's what the answer is. All right, let's look at the next one. All right, here we have, we need to find x. And we have two fractions set equal to each other. All right, regardless of the fact that what's in the numerator and the denominator are fractions and mixed numbers, it doesn't matter. You see these fraction bars here? This means that you've got a fraction here and a fraction here, and they're equal to one another. So every time that happens, it doesn't matter what you have inside, you're going to multiply. You're going to cross multiply numerators times denominators. So the first numerator times the denominator would be 1 over 4 times x. On the other side, we're going to do this cross multiplication. So we've got negative 3 1/6 times negative 1 1/2. So that's what we actually have. That's what we're looking at. This times this and this times this. All right, now we can actually do the calculation. This one's easy. We just put the x next to it. This one's going to take a little work. So we need to turn this back into an improper fraction in order to do the calculation that we have. So in order to do that, we're going to do the process of 6 times 3 plus 1. 6 times 3 plus 1 over 6. All right, we always come back to the beginning by putting it over what is underneath. So we ignore the negative sign. That is just telling us what this whole number is. It's negative. So 6 times 3 is 18, plus 1 is 19. So it's negative 19 over 6 times 2 times 1 is 2, plus 1 is 3. So negative 3 over 2. Okay. Now, one of the things that I like to do is factor if I can factor to cancel some things out. So I know that 6 is 2 times 3. So that allows me to look at this 3 over here and say, well, that's 3 times 1. So I can cancel the 3's because I am factoring out 3. I'm reducing it by 3. So now I have, I'm going to rewrite it here, negative 19 over 2 times negative 1 over 2. That's what I have. So 1 over 4x is equal to negative 19 times a negative 1. Negative times negative is a positive 19. And 2 times 2 is 4. Now that I have it down to one fraction and one fraction on either side, now I'm going to get rid of this fraction. The way we do that is by flipping it and multiplying it. So 4 over 1 times 1/4. If I do it to this side, I have to do it to this side. So this cancels this and this cancels this. So x is all I have on this side. And if you look on this side, this cancels this. So I have 19 over 1, which is just 19. So the answer is 19. All right, and that is what we would put here in order to make this fraction equal to this fraction. All right, so let's look at the next one. All right, in this problem, it says to write each percent as a decimal. All right, so we know that this just means out of 100. So we would put 8.5 over 100, which just basically moves the decimal place 2 spots this way. So it'd be 0.085. That would be the answer that goes here. 0, ignore this. This is just the cursor. 0.85, right? That would be the decimal there. This one takes a little bit more work. We need to put this in a decimal first. So it'd be 9 point, let's see, 1/4 is 25. So 1/2 of that is 1/8. So that would be 125%. Now that I have that in a decimal, and the way you can find that out, just divide it. Just get on the calculator and divide it if you're not sure. 1 divided by 8 is 0.125, right? So 9.0125. So now we take this and we put that over 100. 9.125 over 100. So this is gonna, these two zeros is just gonna move the decimal place once, twice. So we'll have a 0 in front of that. So 0.09125. That would be your answer that you put in right here. Okay. All right, next problem. All right, this is the last one in lesson 109. What number? That's our variable, n. N for number. That's the format of what we're looking for is a number. So I use the variable that starts with that word to remind myself of what format it needs to be in. All right, number is equal 18 and 1/20%. So 18 and 1/20% of means to multiply. So I'm just going to put a parenthesis there. 12,000. This is our problem. So first I've got to turn this into a decimal so that I can multiply. So I'm going to find 1/20. So 1 divided by 20 is 0.05. So that's 18.05%. It's still percent. We just turned this into a decimal times 12,000. Now I'm going to turn this into an actual decimal, not a percent, even though a percent can have a decimal in it, but it's still a percent, right? We didn't get rid of this. So I'm going to divide that by 100. So I'm just going to do that on the calculator. For funsies, 18 point, oops, I must have clicked off of it. 0.05 divided by 100. 0.1805. So 0.1805 times 12,000 is going to be the value of n. So n is equal to, I'm going to take that number and multiply it times 12,000 on my calculator. I've already got it in there, so why not use it? Times 12,000, 2,166. And that's how you solve that problem, right? Pretty straightforward. So you just write 2166 up here. That's just a cursor. All right, that's the last one in 109. So let's do the other lesson that you needed. Let's see. All right, this is from lesson 112. There are 16 marbles in a bowl. 3 are red, 6 are black, 7 are green. So we have 3 that are red, 6 that are black, and 7 that are green, for a total of 16. Okay, so now let's evaluate what we're doing. Jimmy draws 1 marble from the bowl. What is the probability that the marble is either black or red? So the probability that the 1 marble is black or red. So just one event. So here's the black and here's the red. So together, that totals 9. So there's a 9 possible outcomes that we want out of a total of 16 possible outcomes. That's your answer. That's it. That's all you're doing. Okay? So let's look at the next one. A red die and a green die are rolled at the same time. Okay, so we've got 2 dice. What's the probability of getting a sum of 11? Well, we know when we have 2 dice, there's 6 sides on one and 6 sides on the other. So we have 36 things that could happen. There's 36 rolls that could happen. And in order to get a sum of 11, we have to think about all the things that add up to 11. So let's start with 1. This will be the first dice, and this is the second of the die. Okay. So of the 2 dice, if the first one is a 1, we can't roll anything that'll give us an 11 because it'd have to be a 10, and the highest number is 6. So if there's a 2, that would have to be a 9, can't do that. 3, that would have to be an 8, can't do that. 4, that would have to be a 7, can't do that. 5, we could roll a 6 over here, and that would give us 11. So then if we roll a 6 on the first one and a 5 on the second one, then that would give us 11 also. That's it. That's all we can do. 2 rolls. 2 rolls. 5 plus 6 is 11, and 6 plus 5 is 11. So we have 2 opportunities to get 11. So the probability that we'll roll an 11 is 2 out of 36, which we can reduce to 1 out of 18 if we divide the top and the bottom by 2. That's our answer. All right, let's look at the next one. There are 22 marbles in a bowl. Okay, 7 are black, 5 are red, and 10 are blue. Ariella draws a marble from the bowl. What is the probability that the marble is either black or red? So let's see what our total is. That's 12. That's 2. Carry 1. That's 22 marbles in the bowl. Okay, we already had that. Sorry. So 22 marbles in the bowl. So the probability that it's either black or red. So we have to add the black or the red together. So that's going to be 12. So in order for, that would be 12 out of 22 chances. We want it to be one of these. So you're just adding the 2 together that it could be, putting it over your total. That's all you're doing. Now this can be reduced. This is 2 times 11. This is 2 times 6. So we divide both sides by 2. We get 6 over 11. And that would be your answer. All right, let's look at the next one. All right, so in a standard deck of 52 cards, there are 13 of each suit: spades, hearts, clubs, and diamonds. After the deck is fairly shuffled, what is the probability of drawing a diamond? So let's look at this. So we've got 13 spades. All right, that's a pretty sad spade. And 13 clubs. Looks more like a clover to me, always has. Then we've got 13 hearts, and we've got 13 diamonds. That's a total of 52 cards, right? So we want it to be diamonds. So that's 13 possible things. So the probability that it would be a diamond, we've got 13 out of 52 chances. we can reduce this because we know 13 goes into 52 4 times. So it means we've got a 1 out of 4 chance that it is a diamond. And if you think about it, we know we've got 13 equal sets. We know that 1 out of 4 cards is a diamond, right? Think about it, the logic that goes into that. If you have something that's divided equally, then you can reduce it right off the bat. But you've got an equal chance of drawing any one of these 4 things, which is what this says. You have an equal chance of drawing any one of the 4. So you have a 1 out of 4 chance of drawing a diamond. All right, logic your way through some of this stuff. All right, so here we have another compound interest problem. We're going to find the ending balance of a bank account that began with $3,000 and got 9% interest compounded for 4 years. All right, so 3,000 times, we have 9% interest. We've already done that calculation before. This will be 0.09. So times 0.09. Pull up our calculator. 3,000 times 0.09 is $270. So we add that back to the original balance. That's $3,270. That is the balance at the end of the first year. Okay. Now we're going to multiply that times 0.09 to find the balance. So add our 3,000 to that. We're going to multiply that by 0.09 to find our interest for the second year, and then we'll find our balance. So times 0.09, $294.30. So $294.30. Let's add our original balance back. 3,270. So this is our balance at the end of the second year, once we've added our interest for the second year. So we're going to do that again. We're going to multiply that times 0.09. Oops, wrong thing. That's the thing we want. So we're going to add our 3,270 back. Now we have this balance. Now we're going to multiply that times 0.09. And that's going to be 320, and we're going to round this to 79 cents. So 320.79. When you're dealing with money, we always round to 2 decimal places, right? Because that's the way money works. We only have 2 decimal places for change. We don't have 3. So this is our amount of interest that we earned at the end of the third year. So we're going to add this back. 3,564.30. I'm just going to go ahead and do that on the calculator for the sake of making life easy. 320.79 plus 3,564.3, $3,885.09. All right, this is our balance at the end of the third year. We're going to do it one more time to find out what our balance is at the end of the fourth year. Times 0.09 times 0.09. So we're going to round that to 66 right here. 349.66. 349.66. We add that back to this. Okay, so 3,885.09. We add that back together. We got 4,234.75. 4,234.75. That is our balance at the end of the fourth year. $4,234.75. So you see how we did that? You just go through the process. Interest on the first year, add it back to the original balance. Here's your total at the end of the year. Now we take all of that times the interest for the second year, add it back to the starting point. That's the balance at the end of the second year. Now we get interest on the third year. Add that back to what we started with. This is our total at the end of the third year. Interest for the fourth year. Add it back to what we started with. This is our balance at the end of the fourth year. That's how that works. You just keep adding and keep building. You're calculating interest on top of interest. You can see in that first year, we earned $270 in interest. The third year, the fourth year, we earned $349.60. So you can see how earning interest on top of interest grows your interest. It grows your wealth better. So that's what you want. You want a compound interest account. And this is how you would calculate that. There is a formula. I'm not sure if you guys have been exposed to it or not. That does the same thing in one step. I'm not sure. Let me check. Hold on. Okay, so you guys will not get that until Algebra 1. But this is just understanding what's happening. So next year, you'll get the compound interest formula so that you don't have to do 4 different steps. You can do it all in one step. All right, so let's look at the next one. All right, so this is Kevin, the pharmaceutical salesman, receives $510 per month base pay plus 6% commission. So he gets $510 plus 6% every month. So in 2 months, after touring a metropolitan area, he had sold $260,000 in pharmaceuticals. How much did he make in the 2-month period? Okay, so he's got 2 months, so that means he gets base pay times 2. So 510 times 2, because it's 2 months, plus 6%. Now, it's 6% of the total. This is the total that he sold in 2 months. It tells us that right here. In 2 months, he had sold $260,000. So he gets 6% on this $260,000. So if we put that into a decimal, that would be 6 over 100, which would equal 0.06. So we say 0.06 times $260,000. And that's going to give us his pay for 2 months. That's how much he makes for 2 months. So if I multiply 2 times 510, I'm going to get, that's 1,020. So 1,020. And then I'm going to multiply this on the calculator because that's kind of a lot, to try to do in your head. So 0.06 times 260,000. So 15,600. So 15,600. And that's going to be his pay. So I add the two of these together. So plus 1020, $16,620. So 16,620. That's how much pay he received. So you see, you just have to logic it out and think about what's going on, convert your percent to decimal, and then you can do the calculation. All right, let's look at another one. So here we have a sales representative was paid a base salary, $400 a month. And he got commission, 12% on everything he sold. So in 2 months, he sold $260,000. How much did he make? So again, a 2-month period. This time he has a base pay of $400 plus 12%. And this is per month. So in 2 months, we have to multiply this by 2. So 2 times 400 plus 12%, let's turn that into a decimal, that'll be 0.12, times the $260,000. So that's going to equal his pay. So 2 times 400 is 800. And then let's multiply. There we go. We're going to multiply 0.12 times 260,000. 31,200. So 31,200. So 31,200 plus 800 is $32,000. That's how much he made. All right, let's look at the next one. All right, Aries Pet Shop is selling geckos at 12.5% off. If they originally were $20 each, what is the sale price? So first we're going to figure out what is 12.5% of $20. So 20 times, we turn this into a decimal, that's going to be 0.125. So we find that amount. We can do that on our calculator. 20 times 0.125 is 2.5. So $2.50. That is the discount. So we just say $20 minus $2.50, and that is going to be if I take $1, that's 50, so it's 19 minus 2, so it's $17.50 is the sale price of the geckos. All right, so that's how you would solve that problem. Take your time and think it through. Draw a picture of what's going on if you need to, right? If you need to draw a gecko and put $20 around his neck and then say minus 12.5%. The trick here is turning it into a decimal. So you put 12.5 over 100. This takes the place of this. I always would look at that when I was a kid and I would see the 2 zeros. And that would remind me that I need to put them below this bar. So I would take this and I would transform it into this. And I'd put that number over the top of it. That would remind me to do that. That was just the picture in my head that I needed. That this equaled this little thing right here equaled putting it over 100. And that helped me to remember. So when you divide then, when you do the 12.5 divided by 100, that's when you get the 0.125. And then that's what you use to actually do the calculation. So use little things, little tricks like that to remind you, oh, I have to do this. This means I have to divide it by 100. And the 2 zeros here with the fraction bar is what reminded me, right? That's the little trick that I use in my brain to tell me how to do the problem. So do little things like that for yourself, right? If you have to draw a picture of how that transforms, just sketch it out and make it look cool. You'll remember that. You'll see that picture and you go, I know exactly what's going on here, right? So do what you need to do to help you remember the process. Let's do the next one. All right, this one just says to write each percent as a decimal. This is not hard. You can do this. So all we have to do first is get rid of the fraction, right? So 5 1/5%. So 1 divided by 5, that would be 5.2%. Now the way I got that, I just went in here to my calculator and I said 1 divided by 5. That's 0.2. And then I put my 5 back in front of it. So that's 5.2%. Now I'm going to divide that by 100. 5.2 divided by 100 is going to be, let me write that a little bit better for you. All right, so 5.2% equals 5.2 divided by 100. So when we do that, we get 0.052. So you just go back to your calculator and let's add our whole number back to that. That's 5.2%. That's a percent. Now, if your calculator doesn't have that, that's fine. I'm teaching you how to do it without having the percent button. So we're going to divide that by 100. 0.052. Okay. We're going to do the same thing here. We divide 3/4. 3 divided by 4 is 0.75. We add the whole number back to that, plus 17. So 17.75%. So 17.75%. that's going to equal 17.75 over 100, which is going to equal, we're going to divide that by 100, 0.1775. Okay, this one we're going to divide, 3 by 8. 3 divided by 8, that's 0.375. We're going to add the whole number 11 back to it. So 11.375%. We'll put that over 100, which helps us drop the percent sign. So when we divide that by 100, we get 0.11375. So 0.11375. You can see in each of these two zeros on the bottom, they just move the decimal place 2 places to the left, 2 places to the left, 2 places to the left. And that's your decimal. Ignore that one. So 0.052, 0.1775, and 0.11375. Okay? All right, let's do the next one. We're going to use the distributive property to multiply. So we're just going to multiply each one of these times the term that's there. Sometimes when you have these mixed terms, you have these fractions here and whole numbers here, it's easier to turn everything into a fraction. That way you can actually see what's going on. So now you know this is numerator to numerator. So we've got 3mp times 2m over 1 times 1, which is 1. Bring down the operation. We've got 3mp over 1 times p over 1. 1 times 1 is 1. All right, plus 3mp. It's all right if I do pm. I just got ahead of myself. And then we've got m squared. And then we have 1 times p, so it's 1p. Bring down the next operation. We've got 3mp times p4, and we have 1 times m, so that's just m. Now we're going to simplify this. So any whole numbers that we have, we multiply. 3 times 2, that's 6. And we have m once, m twice. So m twice, and then we have p, and that's over 1. Then we have 3m, and we have p twice, so that's p twice, over 1. And then we have 3p m 1, 2, 3 times. So 2 plus 1 is 3. So 3p m cubed over p, plus we have 3m, we have p 1 time and 4 times. So 1 plus 4 is 5. So p to the 5 over m. Now let's see if we can simplify anything else. So if I look very closely, this is over 1. So this just becomes 6m squared p plus, this is over 1. So it's just 3mp squared. Now this is 3p m cubed over p. The p's can be factored out and reduced. And then this just becomes a 1 under the bottom. So this is 3m cubed. And then I bring down my plus, and same thing here. I have an m and an m. I can factor those out, simplify it. So this just becomes 3p5. And those would be your answers. 1 in each of these blanks, okay? And because they're positive, you can just write the term. You don't have to put the plus sign in front of them. Let's move on to the next one. All right, so here we need to find the measures of angles A, B, and C. The first thing that we have to remember is that the interior angles of triangles Let's call this A, D, and E. So A plus D plus E is equal to 180 because all three angles added together is 180. Now I can put in the value for D and E. So I have A plus D is 21 and E is 41. So if I add them together, I get 62. If I subtract 62 from both sides, this cancels. So A is equal to 118. So 118 is the value of A. That's what I would put down here, 118. Okay. So now let's look at finding B. So again, let's call this F and G. Okay. So B plus G plus F is equal to 180. So G is a right angle. So G is 90. And F is 26 degrees. So if I add these two together, B plus 116 is equal to 180. So if I subtract 116 from both sides, B is going to be equal to, excuse me, 64 degrees. So B is 64. Okay. Now the last one. You see these little marks here? We're going to find C. These little marks here tell me that this is an isosceles triangle, which tells me that this angle is congruent to this angle. So if they're the same value, then we can call this one C also. So that tells me that I could, let me scroll this up. I could say, let's call this other angle at the top, let's call this H, right? Call him H. So that means I've got H plus C equals 180. Well, H is equal to 42. So 42, and then I've got two C's. Plus two C's is equal to 180. If I subtract 42 from both sides, this would cancel. Two C's would equal 138. So now that I have two C's, I know I can divide by 2. And this would cancel, leaving C behind. And then this would be 138 divided by 2. That would be 4. And that would be, oh goodness. So that would be 65 plus 4, so it would be 69. Yeah. So each of the C's is 69 degrees. That's right. Yes, that's right, because 2 times 9 is 18. Carry the 1. That's 12 plus 1 is 13. So that's right. Okay, so that's how you would do that. It's all about understanding the properties of the triangle and that the interior angle is always going to be 180 degrees. Understanding that the isosceles triangle means that these two angles are the same, so they have the same value. So you could give them the same label. That helps you do the equation easier. Okay? All right, that's all we had for lesson 112, I think it was. Yeah. So I am about to actually go and get Miss Melanie, pick her up, and we're going to go buy lunch for tomorrow. So I will see you then, sweetie. Bye.